While I have you in a clapping mood, can we give a round of applause to the organizers and the MCs? Because they were not supposed to be doing that, and they were amazing. And it's the end of the day, so super hearty one. Thank you. So I'm super excited about this talk and how the schedule worked out, because we started with art in the morning, and we're going to end with art at night. So it's sort of like we bookcase JavaScript with art, and I think that's really exciting. I'm Monica. I'm not Waldorf on Twitter and internet places. That is my cat. I do like cats. I'm an engineer at Google on a team called Magenta in Google Brain. So I work with a whole bunch of researchers with machine learning, and I'm going to tell you a little bit about that in a little bit, because first, I'm going to talk to you about my favorite topic in the world, myself. If you've ever heard about me, it's probably because I made something really dumb and I put it on the internet and you played with it, because that's what I really like doing. I really like building silly things. And I kept calling them silly for the last 3 or 4 years. And I realized it's not entirely clear what I mean by silly, because to you, silly means something else probably. It might mean that the things that I make aren't serious or aren't important, or I don't care about them. And that's not true. Everything that I make is like my little darling. I put a lot of time in them. Sometimes it takes me 6 months. I love all of them. Whenever I put them out there, it stresses me out. Like every good artist, it gives me anxiety because you're going to look at it and judge it. But silliness to me implies that you can take it lightheartedly. You could call it art, but I don't. Art is a word that I struggle with because I feel like as a society we sort of ruined the word art. When we refer to something as art, we have to judge it. Everybody's been taught to look at a painting and be like, oh, I could make that in my living room. Is it really art? And then you don't enjoy it. You put on your judging hat and you start hating on it. And I don't really want to be on the receiving end of that. And in particular, I just want you to have fun with them. So this is why I call them silly. They're not art, they're just silly things that you can interact with. These are the kind of things that I make. This is called MIDI City 2000, and it literally builds cities out of rock and roll. If you think about a MIDI file, which is this abstract representation for music, MIDI files have different instruments, which you can think about them as rows of buildings, in different places in your city. And at every point in time, you play a note on one of these instruments, and the notes are represented by pitches. So at a point in time, you basically have a pitch, which is the height of the building, and its length, it's a duration. So this is how MIDI cities actually look like cities. MIDI music actually looks like cities. And of course, you can play them, and if the sound gods work with us, it should sound like this. The great thing about this is that once you understand that's what MIDI is like, you can start playing around with this file. You can throw away some of the rows of the buildings. You can increase the density or decrease it between these buildings. And that makes a new song. And it's not a good song. But that's fine. Not all the music that we make is good. Look at a lot of radio stations out there, and we make a lot of garbage. Why not make garbage with JavaScript? Why is that stopping us? And I really like this project. This is my favorite thing that I've ever made, because it's not just visual. It's a really weird and possibly useless music instrument that you can play with. And I like that. It's silly. It's like the definition of my life. The thing about making things, I make them because I like it, but I make them because making things is objectively good. There's a whole bunch of science research that shows that making art actually helps you decrease your cortisol levels. It actually decreases your stress and your anxiety. If you doodle while learning concepts, you form different connections in the brain, and you learn things differently, and it helps you reason through problems. Making things is objectively good. So I make these things because it's objectively good for me. It's how I have fun. But in particular, I make them so that you can also make silly things with me. The things that I built aren't static art that you go and look at with your eyeballs. I make things where you can click on them and you can make music with them. That demo that I showed you is on Glitch. You can upload your own MIDI files, you can play with them, you can download them, you can put them on SoundCloud and call it your new album. Do whatever you want with them. And these are the kind of things that I like. I want to be able to, in some way, help you with your creative process, whether you think you have one or not, and sort of extend it and make a delightful experience out of it. And that's what I've started calling generative delight. I used to call it generative art, but that's a term that already exists and it's well defined, and I kept fucking around with the definition, so I stopped doing that. And to me, generative delight is this idea that I put a bunch of code out there, and then you put a little bit of your creative process in it, and then I throw in like a randomness in the output. And what we get out of it is something that hopefully is, generated and also delightful, generative delight. The first thing that I did around this topic, I've been like working in this area for, and I say working very, very broadly because everything I make is ridiculous, but for like 3 or 4 years, and it's like been getting better and worse at times. The first thing that I ever made was Emojicode, which is a great and fun and useless app where you upload an image and it gets pixelated and it replaces every pixel with an emoji. Excellent. Why wouldn't you want that? And I really like it because, obviously, emoji, but it's not exactly a successful project for that generative delight idea because your creative expression isn't really in there. Like, sure, you pick what image you're uploading, but you can't really control what emoji comes out of it. It's not something that I built in. It, like, picks the emoji that's closest to the color of that pixel. If you're having a bad day and you don't want to see any, like, people in it, tough luck, Emojicode doesn't care. And the other part that I really did not like about this is that random delight isn't in there. Once you look at the screen, and I told you what Emojicode does, you know exactly, well, not exactly, but like you have a very good idea if you upload an image of a cat, what that emoji-lated cat is going to look like. You're going to pixelate it in your mind, and you're going to put a bunch of like emoji of that color. That randomness isn't really there. It's like fairly deterministic. So in order to fix this, because I was sort of in like this slump of not making the things that I wanted to do, I introduced rules. And if you talk to any artist out there, rules are like crucial to anybody producing anything, because if the world is literally your oyster, you're not going to be able to produce something that's very honed in and very specific. And I find the same thing happens in any like programming. If you don't have any rules, the problem is really complicated. You can like pick anything on like the server and the database and your front-end framework and your whatever you want and the language and TypeScript and JavaScript. And if you have to make all of these choices, then you have less time to think about, well, what should your application do? What is the experience you're trying to communicate? So the rules that I introduced were basically that everything that I made had to have emoji in it. The thing that it was going to do is just display emoji somehow to the user. And then once I figured that one out, the thing that I had to focus on was, well, what are we going to do with this emoji? What is this creative expression that I have to do with emoji? Now that I work on a team that makes music, pretty much everything that I build touches MIDI files, because that's the kind of thing that's the kind of rule that I've introduced right now. So the next thing that I built in this project was called Emoji Garden, which generates a random garden of emoji. Things you can control are the size of the garden and the density of snacks and visitors. Things you can't control, anything else. This ended up being a surprisingly wildly popular project for like the 3 hours that it took to make. Top highlight of my life, Susan Kerr, the icon designer, tweeted about it, and then I died a little bit, and I just went home and celebrated. Monica Lewinsky also tweeted about it, so weird parts of my world coming together. But ironically, this was also a failed project for me, because it, again, did not have this creative expression of yours in it. You don't get to control anything. You basically like roll the dice, and it generates the garden for you. Maybe carrots killed your family, and you would prefer no carrots in your garden. Tough luck, Emoji Garden really doesn't care. So this was a bit of a bummer, because I was like, well, I made something really fun, but I didn't make the thing that I wanted to do again. But it turned out to be an extremely successful generative delight project because of the platform that I built it on. I built it on Glitch, which is a platform that basically encourages collaboration and remixes. If you haven't seen it before, this is it. It's basically a really fun and awesome code editor in your browser. It lets you like watch the output, whatever. But in particular, it tries to like build this community around projects, and it encourages remixing of people's projects. So I tend to write my projects in a way where people can look at the code really easily and like change it if they want to. And to me, remixing is the premise of generative art. You take something and you regenerate it in a way that like makes sense to you. So what ended up happening with Emoji Garden is that people took it and they started making their own gardens with it. They remixed it into hedgehog gardens where only hedgehogs and no other animals were invited, into really scary deserts that had scorpions and spiders and like a lot of fires because that was a snack. They made it into a sky because San Francisco has a lot of clouds, and sometimes you want to see a whole bunch of suns in the sky, and they made that. They also made voidscapes, which is my favorite. I don't know what it means, and I love it. It's like absolutely goth. It's the gothiest thing I've seen done with JavaScript. Sometimes you get like ominous eyeballs and labels that say that the end is near and clocks, and I love it. Like if I could just have this projected in my house all the time, I would. It's brilliant. Audrey made this fantastic. So the surprise here in this project wasn't what I made, which wasn't Generative Delight, it was Glitch. The platform made it generative, because the thing about art, or really anything, is that we don't make it into a void. We live in this weird online world where everything is online, happening all the time, everywhere at once. And the code that we use, the devices that we distribute it on, the way we put it out there, all of these shape the end result of what you're making. And in here, Glitch shaped my project, and it was wonderful. And it wouldn't have been a successful project if Glitch didn't exist. This isn't a weird thing. Like if you think about like an oil painter, if you take away their oil paints and you give them like thumbtacks, they're still going to produce art. It's just going to be very different that the thing that they were going to produce with oil paintings. The same is going to happen if, you know, I give you only a row of pixels and you have to produce art with it. You will do it. It's just going to look different, because everything that we rely on is important for creativity. And this is absolutely true of code as well. The reason why Emoji Garden was so easy to remix is because of specific code decisions that I made. And I'm going to tell you a little bit about this in a second. Because if you want to build visual things, you should use visual libraries and things that help you with it. Think of something like Processing JS. It's a library that's literally built for visual things. So if you want to build something visual, Processing will help you with it. If you want to build something visual, you're probably not going to reach for C++ unless you like pain and memory leaks. That's not to say that you can't produce art with C++. You absolutely can. Like there's wonderful OpenGL shaders and stuff in games, and every video game, in my opinion, is art. It's just going to be harder because all of this time that you have to spend, looking for pointers, checking to see if you've shot yourself in the foot when you're managing your memory and all of that stuff, that's less time that you have to be creative and to paint things on the screen, which was the thing that you originally wanted to do. You wanted to give the user some pixels. So Emoji Garden uses this library called Tracery.js, and Tracery.js is built by Kate Compton for procedural art. And it's a super simple library that I want to show you how it works, because without it, Emoji Garden wouldn't have been possible. So in Tracery.js, you basically define your world as a grid of available tokens. So here, I think I picked M for either Monica or model. I don't remember. It was late at night. V for visitor, and S for snacks. And this is what basically every garden looks like, and I just randomize where these go. I roll a dice. So I tell Tracery that this is my pattern, and then I also tell it what values you can put in. So I give it a set of tokens. The model can be cactuses and empty spaces. The visitors can be a mouse and a delightful little hedgehog. And then you give these two things to Tracery, and then Tracery basically goes token for token and picks a random value from the world. That's all it does until it fills the entire grid. This isn't hard. I could have written this for loop. I'm competent at writing for loops. I could have done this. It's for loops and JavaScript random numbers, which, while weird, are not that hard. But I didn't. I used a library that was made to help me with this, because that means that if somebody wanted to remix this project, they didn't have to know or read my for loops and weird functions that I declared. All they had to do was change the values of these tokens in the world. Just change those, that world object, and everything else would get regenerated after they how they wanted. And this is why a lot of people that weren't even programmers managed to take Emoji Garden and make their own gardens out of it. And it was really great, and that's what made it, delightful. The thing about Tracery is that it's a serious library. It's built by a serious person for serious things. People use it to generate levels in video games or poems or stories or anything that you want. People also use it to make a grid of ominous eyeballs and doomsday clocks. And I think that's a really important thing, because the thing about art is that you don't have to get it. Somebody out there is going to get it, and it's fine if you don't get it. I don't get Roy Lichtenstein. That doesn't stop the MoMA from putting pictures his paintings in their museum. So if we agree that making things is objectively good, then we should also agree that helping people make these things is also objectively good, and in particular, it's important. So when I came to this conclusion, I was like, oh shit, this is what I want to work, this is what I want to get paid for, helping people build sillier, artsy, creative things. And that's how I ended up working on Magenta, which is the team that I work on now. So Magenta is a team of researchers and a couple of engineers and a front-end engineer and me. And the researchers are super smart and brilliant and do machine learning research where they create these like brilliant models that are able to generate music. And then I come in and I try to make a little JavaScript delightful interaction with it so that other people take these models and actually do useful things with them. So the role of this team is to explore the role of machine learning in the creative process, not replace the creative process, but sort of interact with it and see how we can help artists, musicians, and creators use machine learning to like make awesome shit with it. Because for better or for worse, machine learning is like the hot new shit right now. It is a word that's being thrown around everywhere, from like selling you better ads to selling me shoes on Instagram to cancer cells to self-driving cars to anything you want. So why shouldn't it help us with music and art? Why is that a lesser area that we shouldn't be focusing on? So before we even like talk about music and art, I want to give you like the 2-second introduction to machine learning, because if you haven't heard of it, I don't want you to like feel bad, because machine learning is really not that special. It's like a glorified function. We know functions. We've been writing algorithms and functions for like all of our professional life. A classic algorithm or function is to double a number. This one's an easy one. You put in a number, you double it, and that's what our function looks like. For any x, we can double it. We can have more complicated functions or algorithms, like what would be the function to get from here to the closest Kaya Toast place. There's like algorithms for this, like Bellman-Ford, or like better ones, because Bellman-Ford is from like 30 years ago, and it probably doesn't actually work with maps. But we have this, we can do this. It's not super hard. But we have like functions that we don't really know how to write. Like, how would you write a function to decide if something's a dog or a cat? So if I put in a dog, it says dog, and if I put in a cat, it says cat, and it does so reliably. So if I put in a fancier kind of cat, it still knows that it's a cat, and if I put like a sausage dog, it tells me it's a dog and not a sausage. But I don't know how to write that. Like, what is a cat? Is like an existentialist crisis in my life because I live with a cat. Like, what is a cat? Is it a lump of fur that just sits there and judges? Can I write that in binary? No. Can I write that in JavaScript? Absolutely no. You can start thinking about heuristics, like what makes a dog. Maybe if it has like beady black eyes and like a snout but no whiskers, that's a dog. But if it has whiskers, it's a cat. But there's dogs that have whiskers, and there's cats that look like dogs, and there's blueberry muffins that look like dogs. So that is just not gonna fly, right? That's not a function that we know how to write. If you Google this, you're gonna get like tons of like dogs that look like foods, because that's what we do if we write functions. So that's where machine learning comes into play. Machine learning is just a different way of writing these functions so that it figures out what that function is by just feeding it examples. I don't need to know what makes a dog a dog. I just need to give it enough examples of a dog so that if it sees any dog, it goes, yep, that's a dog, because that's what we really do as humans. We've seen a lot of dogs in the world. That's how we know what a dog is. So the way we train these models, and what I mean by model, I mean this function. Whenever you hear a machine learning person be like, I use the model to predict, they just mean what is the output of the function. So to train this model, we basically feed it by hand, labeled examples. So we know this is a dog and we know this is a cat. So we feed it a picture of a dog where we know what the answer is, but we don't tell it. We're tricking the model because we're cruel like that. It's like those people who are pushing those robots, like the robots that look like dogs, and they're like putting all these videos of like, look at this dog falling over and getting up. They're the first to die in the robot apocalypse. Not us, we are nice, we're feeding it pictures of dogs. So we put in this picture of a dog and we're like, hey model, what is it? And the model doesn't know at this point, so he goes, is it a cat? And you're like, no, that's silly, this is a dog. And then you give it a picture of a cat and the model goes, I don't know, is this a cat? And you're like, very good model, you're doing great, that is a cat. And then you do this 1,000,000 times. And I'm not kidding about this, I literally mean, like the data sets have 1,000,000 data points of dogs and cats. And the model looks at it over and over and over again until it goes, listen, I think I got it. Most of the time, I don't get this wrong, and I think I know it. So then when you show it a picture of a dog, it goes, yes, it's a dog, and you're like, absolutely, you did it. Of course, this depends on like what kind of data you're putting in. If you're only putting in pictures of cats and golden retrievers, machine learning isn't magic. This function isn't magic. If you show it a picture of a beagle, but you've only trained in golden retrievers, it's not going to know this is a dog, and it's probably going to flip a coin. This is how we get racist algorithms in the world, by the way. It's because we only feed it pictures of white people, and then we ask it to categorize a black person, and it goes monkey because it hasn't seen a black person, because you're a terrible engineer, and what are you doing with that data? This makes me really angry. So training data is really important. So this is how we train a machine learning model. See, it's not, behind the scenes, it's really complicated, but it doesn't matter, because what we need to understand in machine learning is how, the basics of it and how it works. So machine learning isn't particularly new. I think the first neural networks were in the 60s and the 70s, so we've had quite a long time with them. But they haven't exploded to 5 or 10 years ago, really 5 years ago, because we used to suck a lot in machine learning. Our computers were really slow. We didn't have GPUs, so we were really bad at doing matrix math. Machine learning is all matrix math nowadays. And in particular, we didn't have any of these training data sets. Like the cats and the dogs that I showed you, we didn't have a million data points. And if we did, they were really pixelated. So we weren't really able to generate really good cats or dogs. So we've gotten really good at this because the methods got better, the algorithms got better, GPUs are powerful, and we've sacrificed a lot of goats and firstborn, and now we have incredibly fast computers, and it's great. So because we're really good at this, we're also really good at generative models. So the model that I showed you before is called a classifier. What it's really good at is basically labeling data. It looks at a cat and goes, yes, it's a cat. A generative model is something that, without any input, generates something. So for example, it would be able to generate cats and dogs that look like the cats and dogs in the data set, but aren't memorized. They're just like them, but not exactly the same. And we've gotten really good at these too with a model called a GAN, a Generative Adversarial Network, which is notably really good at generating faces that don't exist. It's wildly creepy. This is a set of websites that used to exist that got taken down because holding servers up is hard. But none of these people are real. These people don't exist in real life. These people are the output of a machine learning algorithm that is really, really, really good at generating believable faces. And if you want to know about how this works, come chat with me later. It's actually really interesting. But this is the thing that we're really good at. We're really good at generating cats that don't exist. And sometimes they have weird artifacts, like the one on the unicorn side of the stage, but they're still very believable cats. We can generate rooms that don't exist. All of these, by the way, are because, for better or for worse, these are the data sets that we have. So machine learning researchers are well, the data sets that I have are people, cats, and Airbnbs, so let's do it. But none of these rooms, again, exist. This is a completely, a machine learning algorithm dreamed up this bedroom that now exists and is going for probably £1 billion in London. But we're not just good at images. We're also, in recent time, became really good at music. So a transformer is a different kind of model that's usually used for language. But music is a little bit like language. So now we're able to generate things that sound like this. And it goes on forever because the model doesn't know how to end songs. That's based on research by one of my coworkers called Anna Huang, and she's brilliant and she's going to solve music. So it's really great. We're able to generate music, but what does that mean to a musician or to an artist? Because I don't want somebody to generate music for me. I want them to generate music with me. I want it to be a really smart instrument. Because we live in this world where technology is everywhere. My kitchen faucet is literally voice activated. I can tell it to dispense me a cup of water. It's helpful sometimes, not helpful most of the time. But I play music in the same way that I did 15 years ago. I have a physical piano, and I sit at it, and I'm still really bad at composing, and I make a lot of mistakes, and nobody tells me how to fix these mistakes. And what I want in the world are these better, weirder, more surprising, more inspiring, more configurable instruments and interfaces to make music that can help me make better music, because that's what I want to do. Interfaces like this. This is a demo made by Taro using one of the Magenta models. So he basically generates a whole bunch of melodies with one of our models, and then as you go up and down, the key that that melody is in, and as you go left to right, the melody changes. So with this instrument, you can make things like this. And that's a good song. We also had something like the Google Doodle that you may have seen for Bach's birthday like about a month ago, where there was this little app that let you enter a melody and it would like harmonize with you and make a Bach-sounding 4-voice chorale. And this was a fun little game, but we also explored what it would look like if we're going to build like a fuller instrument for somebody to compose with. So I built this like side app for it where you basically get to like interact with the model more. So you get to like draw a little melody. Which you might recognize as the legal version of Seven Nation Army. And then we can ask the model to like fill in this melody and give us the other 3 voices. But then we can also play with like whatever attributes the model exposes. So temperature is a thing that in machine learning sort of means a randomness. So if I decrease the temperature, sort of like the entropy of it, it's conservative. Or I can crank up the temperature and make it like super random, and it's going to put a lot of like arbitrary notes in there that don't really match and make Bach like shudder. And at this point, like everything is configurable. You can start like erasing some of the notes, asking the model to like infill a particular section, maybe throw away a whole bunch of things, and like try to play with it and compose in this app. And at the end, you can download the MIDI, and it's your MIDI. You've composed a new melody with it. And these are the kind of things that we want to build. We can also build weird interfaces where we figured out there's a model one of our residents built where you summarize 88 keys on a piano to 8. So rather than playing the whole piano, you can play 8 of them. And you're really prolific and great, and you might be like, well, that's silly. What applications do you have of this? But the Flaming Lips used this at Google I/O for their concert, but rather than playing 8 buttons, they played fruit. We connected those 8 buttons to a makey-makey, and then as they were playing the fruit, the model would like make the next correct note, and like it was a really fun interactive thing. We've also built a set of Ableton plugins because it turns out musicians live in Ableton. So we were like, well, what it would look like if we put these machine learning models in Ableton? Would that be useful? And you can go read about them because I'm already going to be 5 minutes over time. And we can do this with art too. We don't just do it with music. Most of us are musicians, less artists. Nobody cares about me. We have models that have looked at people sketching things, so they're really good at drawing cats like a million people draw cats. So I built this silly thing where you start drawing a cat, and then the model continues it for you, and then you can draw a whole bunch of different animals, like a crab, or a truck that's going to be off screen. It has wheels, pinky swear, or a whale. And this isn't art. I understand this isn't art. When I said that I have a problem with the word art, I understand fully that you should judge this. This is not art. But it doesn't mean it can't be. First of all, kids love the shit out of this. And second of all, if you spend time like putting a model that also understands painting and stuff like that, you can start making believable things with this. The things that we make on the Magenta team isn't like products that we make money out of. We make models and then experiences so that people can use them and you can make money out of it. And the thing about all of the demos that I showed you, literally all of them, is that they're all done in JavaScript. We have a library, it's open source, it's called Magenta JS, and it's built on top of TensorFlow JS in such a way that you can use all of this machine learning without having to know what machine learning is. The models are pre-trained, the APIs are super simple, so that you can take them and just make whatever your heart desires, and it's really easy. That spinners, the incredible spinners, the way those random melodies were generated is with this model called Music VA that's good at generating fairly robotic sounding music, let's be very honest. So you create a model, and then you ask it to give you a sample, and this gives you back a sequence, which is a lot like MIDI. It's just like an object that looks like MIDI. And then you can create a player, which wraps Tone.js, because making web audio in the browser in 2019 is actually still horrifyingly hard, and you should never do that. So the player does all of that heavy lifting for you, and then you give it the sequence, and you go player start, and then you can hear it in a synthesizer or a piano or whatever you want. And I'm not like pulling your leg here. It's literally like 4 lines of code to generate infinitely sounding melodies. Maybe you want to put that into the Bach chorale. You can take the sequence that, again, the robots generated for you. You can create the other model called Coconut, which is the one that does the Bach infilling. And then you can ask it to infill that sequence. And it gives you back a 4-voice sequence or a chorale. And then you can, again, pass that to the player and go, player, play me this. And this is exactly how you generate all of those chorales in the demo that I showed you. The piano genie with the 8 buttons, super similar. You create the model, you ask it, you tell it that you've pressed a button and like how random you want the output to be, and it gives you the next note over and over and over again as you're playing it. And the reason why we work on this library is because we really believe that code should never hold back art. If that API looks surprisingly easy, it's not random, it's a deliberate decision. Because when we're meeting with musicians, it turns out musicians don't really know how to install Python and Python dependencies and get our Python code that would take like 17 command line parameters to work and then would give you like a MIDI file in your temp directory. Musicians don't really know how to do this. They use Ableton. And we want people to build tools for musicians because that's the people that we want to interact with, artists and creators, not just like engineers who really want to write snakes on their computer. Snakes is what I call Python, feel free to take that one. Spiders is what I call JavaScript, feel free to take that one too. And this makes sense. If you think of your favorite painter or like artist, Degas is one of mine. Degas didn't make his own pastels. He bought them from Sennelier, which was a man who spent his entire life making chalk pastels. He couldn't draw worth shit, and Degas couldn't make his own pastels. Yo-Yo Ma doesn't build his own cellos. He like buys them from people who made them in the 1600s. The artists shouldn't make the tools to make the art. They're there to make the art itself. Because at the end of the day, the medium influences how the message is perceived. This is a quote by Marshall McLuhan, who is a Canadian, go Canada. But it's trying to tell you that like models don't exist in a void. They exist in like this artistic environment that we live in, and how we deliver these models to people and what you do with the models is the thing that matters. That is the medium. So I want to show you, I'm going to end with like these examples of a couple of art installations. Remember the creepy generated images of people that don't exist that we're really good at? Mario Klingemann has an art installation, has several art installations actually, that uses that algorithm to generate infinitely many portraits. So as you come into this room, these paintings of people just get generated forever and ever, and you can look at them. The thing about this installation is that it wasn't possible 5 years ago. It wouldn't have been possible without these machine learning algorithms that we have today. A painter is not able to generate infinitely many portraits. We can't count to infinity. It's like a lot. It takes a bunch of time. So this is a way that we can use machine learning in art and still maintain that integrity of art. This is one of my favorite things that I've ever seen in my life. It's an art installation called Peeping Skulls by Robbie Barrett and Ronan Barrow, same name, different people. Robbie Barrett is an artist that does a lot of art with artificial intelligence, and Ronan Barrett is an oil painter. So they got together, and based on Ronan Barrett's painting style, Robbie trained a model to generate skulls that look like Ronan would have painted them. And they actually exhibited this as an installation next to physical paintings of these skulls in a museum. And what happens in this installation is that you walk up to it, and then you look, and it tells you what's about to happen. You're going to get generated a random skull that looks like a Ronan Barrett oil painting. This is this one. And you get to look at it for 5 to 10 seconds. And then it disappears forever. And it's been marked in the machine learning algorithm so that it can never get generated again. If the machine learning algorithm tries to generate this again, if the model does it, it's going to try to generate another one. This was your skull, and your skull alone. And in this weird Instagram world where we post like our entire lives to stories, this is like an amazing commentary about this intimacy of this art experiments where we can all experiment, like we can all live this experiment, but never share what we actually saw. And I think this is fantastic. There's this great quote from Brian Eno that says that what you now find weird, ugly, uncomfortable, and nasty about a new medium will surely become its signature. The distorted guitar sound is the sound of something too loud for the medium supposed to carry it. Everything that you love in the world right now has at one point been judged and looked down by people, probably white men. From weird music, to impressionism, to cubism, to assembling your own Swedish chairs in your living room. And making art with AI and math and algorithms isn't new, and maybe feels uncomfortable now, but that doesn't mean we shouldn't encourage it to grow, because I think it's got great opportunities. And I think this means that a lot of us should start making really serious things so that, somewhere out there, somebody can make a random painting of a skull that exists for 5 seconds and then it disappears forever. Thank you.